Any opinions, findings, and conclusions or recommendations expressed in this material are those of the authors and do not necessarily reflect the view of the National Science Foundation. Data for this presentation was obtained through the use of resources provided by an NSF ATE grant. A fundamental definition of a technician is a person employed to look after technical equipment or do practical work, or an expert in the practical application of a science, or a person skilled in the techniques of an art or craft. The manufacturing production technicians use combinations of electrical, electronic, mechanical, hydraulic, pneumatic, or computer technologies to set up, test, adjust, monitor, maintain, and troubleshoot manufacturing machinery or equipment, monitor and adjust production processes or equipment for quality and productive. In 2004, the National Science Foundation began to invest in the restructure of the ET education infrastructure in Florida by supporting the Florida Advanced Technological Education Center, FLATE, as a National Science Foundation Center of Excellence. FLATE's goal is to design an engineering technology program that meets industry needs and can adjust technician preparation to meet the changing skill requirements as dictated by Florida manufacturers. Today, the AS degree in engineering technology is offered from Florida's far west in Pensacola to the far south in Key West. This presentation, Future of Work Issues for Florida 2-Year Engineering Technology Program, demonstrates how the impact of Industry 4.0 technologies and Florida manufacturers' adoption of these technologies are being identified and inserted into Florida's engineering technology degree. The degree has a 60 credit hour structure that includes an 18 credit hour core and a selection of possible specializations. This statewide degree in engineering technology has several entrance pathways, with the first year of study focused on universally needed technician academic skills and knowledge expectations and general education requirement. The second year's focus is to present technician expertise, skills, and knowledge that will bring the new technicians into the technical workforce. The courses in the specializations are tuned to the manufacturer's needs in the region the colleges service. The course content emphasizes the skills manufacturers need in their technical workforce. However, extended features of the degree highlight the multiple career path options. The degree's first year of study distributes this technical knowledge over a range of core courses. The ET core courses are Engineering Graphics, Industrial Safety, Instrument Techniques and Measurements, Introduction to Quality Control, Microcomputer Applications, and Survey of Electronics. The ET Advanced Manufacturing Specialization courses are Automation Process Control, Hydraulics and Pneumatics, Industry Applications using PLCs and Robots, Introduction to PLCs, Mechanical Devices and Systems, Motor Controls. This particular set of courses in this menu was developed at the State College of Florida in Ocala. The other 20 colleges offering this specialization have their own selection of courses related to their manufacturers' needs. Engineering technology specializations include advanced manufacturing. There are 21 of the state colleges offering this specialization. Other specializations include advanced technology, alternative energy, biomedical systems, digital design and modeling, digital manufacturing, electronics, mechanical design and fabrication, protection and control technology, quality, and supply chain automation. These specializations and their spread of topics are driven by direct information acquired from manufacturers in Florida. FLATE organized and conducted a set of caucuses that included 133 manufacturers and faculty and administrators from each of the 26 state colleges, also shown in this graphic. State colleges are designated by the stars in the blue circles. Industry 4.0 technologies have been identified and conveniently clustered by a graphic developed by the Boston Consulting Group. The technologies in this array are autonomous robotics, simulation, horizontal and vertical integration, industry Internet of Things, cybersecurity, the cloud, additive manufacturing, augmented reality, and big data and analysis. Caucus results included identifying a subset of Industry 4.0 technologies that are important for technicians in Florida. The results also included identifying skills groupings within these technologies. For autonomous robots, the skills were programming, system integration, and repair. For additive materials, the skills included 3D CAD, printing, prototyping, CNC programming, precision manufacturing, fabrication, and material testing. To keep within the vocabulary set by the manufacturers, Caucus manufacturers wanted to lump additive, subtractive, and advanced material skill sets as one needed category. For Industry Internet of Things, the skills were machine-to-machine internet, communications, and record storage data. For simulation, compare process alternatives and identifying effects of process response to change, and participate in developing existing new operations. Remember, when matching technician education to your manufacturer's needs, the manufacturer's choice vocabulary has to drive your effort. The Florida manufacturer's skill descriptors identified here are not prioritized. The list does include skills like critical thinking, diagnosis and understanding the full process, integrating systems, interdisciplinary skills, and technician involvement in engineering. With the skills identified, the caucus participants ranked them within the Boston Consulting Group skill areas associated with technician activity. This table shows the ranked skills with the appropriate Boston Consulting Group category in the column on the far right. The column on the far left shows the manufacturer's rated scores. The table does not show skills that acquired rankings of less than 20% by both manufacturers and faculty. One challenge in presenting these caucus-identified skills within a structured and content-focused degree is suggested with another slight tweak on David Fitzsimmons' hierarchy of difficulty theme cartoon. The success of a statewide single ASEE degree offered in 23 independent state colleges and has no restrictions on its geographic location requires standards and achievement benchmarks within those standards that are followed by all faculty teaching in the program in all the colleges offering the program. This is a sample of the advanced manufacturing standards that the 21 college offering the advanced manufacturing specialization follow. Example benchmarks are shown here. Returning to the Florida manufacturers list of technician needed skills to meet the Industry 4.0 technology expectations, do these skills blend into the Florida standards and benchmarks for the ET degree? The project determined that 33 of these skills are already covered. Establishing skills connections to the Florida standards and benchmarks for the ET degree generated the need to answer two questions: why no standard, and what to do about it. The standard is missing, even though Industry 4.0 technology needs that technician skill, but the colleges have not caught up with that demand. Or the skill in question is beyond a reasonable expectation of a new technician. Returning to the missing standards, cloud skills, for example, one reason why the standard might be missing is the focused silo-style instruction of information technology in technician preparation programs. If information technology and operational technology faculty don't interact, developing appropriate standards on IT and OT skill intersections will be difficult to accomplish. Manufacturers indicate that cloud information technology skill expectations for manufacturing technicians depends on their overall experience with operational technology. The project team is interacting with Daytona State College to use an advanced technical certificate as a mechanism to meet both knowledge and standards needs. Remembering that the two-year program for the AS Engineering Technology degree is available at 23 independent Florida State colleges generates a challenge as to what to do about a missing standard. The Advanced Technical Certificate is an excellent tool to recruit for the task. The certificate generates senior technical expertise that meets advanced technician, that is ASEE degree holder, skill expectations, and BS Engineering Technology degree with initial skill expectations. This ATC contains approved standards and benchmarks as part of the two bachelor level applied degrees, Bachelor of Science and Bachelor of Applied Science. The table indicates the certificate developed for the manufacturer-identified needed skills adjustments. With this certificate in place, ASET degree program faculty can also insert selected certificate lessons and hands-on activities into their two-year program courses with the Florida standards and benchmark requirements already established. A review of the manufacturer-identified needed technician skill categories also produced a group of cross-cutting skills expected of the technician in all workplace situation scenarios: critical thinking, diagnostic and understanding of full process, integrating systems, interdisciplinary skills, technician involvement with engineering. This last category is a combination of three industry-identified skills: identify opportunities for improved production, integration of engineering technology, advanced manufacturing and computing, knowledge of product standards and regulations. The caucus results summary: bring Florida manufacturers and college technician preparation programs together to discuss Industry 4.0 technology issues. Identify manufacturer-defined Industry 4.0 technology-driven technician skill needs. Determine and establish identified needed skills Florida Department of Education standards status. Develop and implement mechanism to insert new Industry 4.0 identified technician skills into technician development programs. Identify for instructional emphasis Industry 4.0 cross-cutting skills.